In problem 43, we start with the fact that we're on a moon, and that on the moon the acceleration due to gravity is 1.6 meters per second squared. First of all, make a note that this is downward. There's a couple ways you can deal with this problem. For me, because we're going down, I'm going to say then that acceleration is negative 1.6 because we're going down. There's one important thing you need to understand, and that's this, that if an original function gives us distance, its derivative then gives you velocity, and the second derivative gives you acceleration. In this case, we're starting with acceleration. We're starting with the second derivative, and that's in terms of time. The acceleration is constant, so f double prime of t just equals negative 1.6. Let's look at part A. We're told that a rock is dropped into the crevasse. Okay. That tells us initial velocity. And that when we drop the rock at 0 seconds, it is traveling at 0 meters per second. We want to know how fast will it be going just before it hits bottom at 30 seconds later. To figure this out, we need the velocity function. We're given f double prime. We want f prime. To do that, we take this antiderivative. If you're given a constant, then you just stick a variable next to it, because we know that the derivative of negative 1.6t would just be negative 1.6. So that checks out. Now don't forget to add your plus c. This is really important. To figure out what c is, we plug in a known point. We find that 0 equals negative 1.6 times 0 plus c, c equals 0. Thus, our velocity formula is f prime of t equals negative 1.6 t. The question asks us to find how fast this rock will be going after 30 seconds. We're given, or we just found, that velocity in terms of time is negative 1.6 t. We plug in t equals 30. We find f prime of 30. We get negative 1.6 times 30, which in this case gives us negative 48 meters per second. So this rock is going 48 meters per second downward. For part B, we now want to know how far below the point of release is the bottom of the crevasse. How far is looking at distance, which means we want the original function f. We have f double prime of t equals negative 1.6, f prime of t equals negative 1.6 t. We want to find the antiderivative of f prime, so we find f of t, which is going to be negative 1.6 t squared times 1/2 out front plus the constant c. F of t equals negative 0.8 t squared plus c. We're going to just let the initial distance be 0. So we'll say at 0 seconds we are 0 meters. We plug this point in to find c. So we have 0 equals negative 0.8 times 0 squared plus c. 0 equals 0 plus c, c equals 0. Thus, f of t equals negative 0.8 t squared.